Hello everyone, this is Mandeep Singh Shekhawat and today I am back with another video which is extension of the previous video which we created earlier, QALM. In QALM we discussed how Uber designed their load setting system. This and in that video we specifically talked about Cinnamon, which we will be introducing in this video. So Cinnamon is a improved version of QALM. There were like some of the issues with the QALM. We will be discussing those, what were the issues and how Cinnamon solves those issues and how it works at scale. So in this video, this is basically a three-part video specifically related to Cinnamon. In the first video, we will talk about the high-level architecture. In the follow-up two videos, we will talk about two key concepts which are used in this architecture. Cool. So let's get started. So again, as always, this video is based on the Uber engineering blog Cinnamon using century-old tech to build a mean load shader. Cool. So when century-old tech, it's just that there are some of the algorithms which are used, which are pretty old, and we are using some enhanced version of those to solve the software systems. Okay, they were earlier used in the mechanical systems, but yeah, they are applicable here as well to solve the problem in computer science as well, so we are using that. So let's get started and we will start with our notes. I have created the notes with whatever information I can understand, whatever information I can gather from the engineering blog, or like mostly focused on the engineering blog. So let's get started. Cool. Now before like going into QALM specifically, like what were the issues with QALM, let's talk about the requirements once again. Okay, so like before starting with any problem statement, we should be clear with the requirements, right? So what we want is in the requirement section, said low request so shed or drop low priority request or higher priority requests if system experiences unexpected load. Adjust the amount of load shedding using PID controller idea. This PID controller idea is one of the concepts which we will be talking in the follow-up video. Okay, so in this video, just assume that we have a system or like we have some kind of algorithm which is PID controller, and it somehow help us to minimize the number of requests in our system. Cool. So it's a basic requirement, right, of a load service system. Like if there are higher priority requests and there are lower priority requests, and if the system is experiencing unexpected load, then we are shedding or we are dropping the low priority requests. The system should automatically work without needing any configuration such as queue size or allow delay between the requests. So like this was one of the requirement in our previous architecture as well, QALM, that we want to minimize the number of configurations we are maintaining, right? And in QLM, like we did reduce the number of configurations, but we still keeping this delay, target delay basically. All right. So this was one of the configurations. There is another thing that one of the another problem which we will be discussing in the follow up. But yeah, the system which we are designing right now, we don't want to have any dependency on the clients. The clients integration should be as seamless as it could be. Okay, so this is one of the again another requirement which is important to our system to work at scale. Additional requirement, dynamically adjust the capacity of the service using TCP/Vegas algorithm. This again we will not discussing in this video, so just forget about it. Okay, on the NFR part, non-functional requirements, we discussed the functional requirements. Now about the non-functional requirements, should not add too much overhead of the request. Cinnamon overhead is around 1 microsecond. When I say overhead, right, so whenever a request arises to a system, okay, let's say this service one, so this request is passing through Cinnamon architecture, right? The new our framework or architecture which we are designing, the request is passing through that Cinnamon, where we are figuring out if I have to process this request or I have to drop this request. Okay, so there should not be too much overhead, there should not be too much overhead created because of that whatever logic you are applying. Okay, I don't care about the logic with PID controller or TCP Vegas algorithm, whatever Vegas algorithm you are following, it's just that the overhead should be as little as possible, and Cinnamon offers that within 1 microsecond. It's pretty good. Cool. Easy onboarding of the customers. This again we discussed in the last video as well. If you are designing any platform service, the client integration should be as seamless as possible. Okay, there should be no configuration requirement. There are like pretty less configuration in case of QLM as well, but as I mentioned, there was one configurations, and that too has to be figured out, right? So we are not doing that. Okay, another configuration which we discussed, that they have to define the priority, right? The clients has to define the priority, and we will be discussing like how it can cause problems. We discussed one of the uh, thing around uh, priority registration. Cool. So there is some issue which is caused by the QLM in that. So we have used the word QLM too much in this video, and if by any chance if you have not seen that video, so I will recommend either you read the Uber blog, okay, or you watch the previous video so that you get the clear idea about what QLM is. QALM is QoS aware load manager. This is what QALM is, and what were the how it basically works, okay, so that you will be able to relate why we are coming up with a new architecture. So in QALM we defined Codel algorithm, controlled delay algorithm. This monitors the queue size. So there is a buffer queue which is defined, and based on that queue uh, you identify if this request has to be dropped or not. Okay, so monitors the queue of incoming request, monitors the queue of incoming request, and how much time each request spends in the queue. If all the requests are delayed by more than say 5 seconds, 5, not 5 seconds, it's too much, 5 seconds is too much, 5 milliseconds within a 100 millisecond window, we discussed that it's a sliding time window approach which we are following there, then Codel sets the request. For QALM it would then reject any lower priority request. Great. So we are clear with the QALM. Now, what are the limitations? Think about it. What are the limitations? One thing is each service. Okay. So uh, we mentioned something around priority registration. So let's say you have this. Let's talk about this architecture. So this is like the front end service or edge service, right? The request arrives here. There are two requests which are coming here. One is from the testing system and one is from the Uber Edge system, direct customer clients, okay, ride booking clients. Now this is the high priority request, this is the low priority request. Okay, now this service one, then it's invoking service 2. Cool. Now there is no way that this service 2 will know if this request is higher priority or lower priority. Let's say right, how will it identify? The service one is registered with a particular API endpoint, and there is a single priority which you are defining. So how will you identify what is the priority of my request? How will you set it? So it's the first bottleneck which you are creating. So among the chain of callers, if there are multiple callers involved in a particular API invocation, it will definitely happen, right? There are a lot of microservices and they interact with each other to figure out a specific result of your operation, right? And then it will create a problem to figure out the actual priority of the request. Great. So priority of the caller, it's hard to define this in the chain of callers. Great, we are clear with this. Maximum number of concurrent requests to be handled, it can change on the request patterns and hardware it is running. Now one thing is that we mentioned that it should be as dynamic as possible. Cool, it should be as dynamic as possible. Now if you are modifying the hardware, right? If you are modifying the hardware, or there are some request, when I say request pattern, it's basically, let's say some services operating at very high TPS, some services operating at very low TPS. So there is no clear roadmap to figure out a single configurations which can work for all, right? This specifically we will not be discussing, but the idea is that to manage the queues, Go uses channels. Okay, so channels is basically your buffer queue in which your requests are storing, and this works on the principle of synchronization, basically to avoid uh, race conditions. Okay, so and if you are adding a logic to handle race conditions, then it will take more time to basically do that. Okay, if it's much similar to your stronger consistency or eventual consistency, if you are trying to ensure stronger consistency, the results will be good, but it will take time. Okay, and it's costly operation basically, and if it's eventual consistency, then it's a less costly operation. So the similar idea applies here. Now we discussed what are the problems, right, with QALM, and these problems are fixed by the cinnamon. What are the problems? Better priority propagation among the services. So one of the problem is that we are not able to propagate the priority among the chain of callers. So we will be able to do that with the help of cinnamon. Cool. Requires zero configurations to use. So in case of cinnamon, clients has to define nothing. Clients has to define nothing, and it's a performance system which is, I mean, yeah, if you are designing a system which is an improvement over the earlier system, so definitely we want our system to perform well as compared to other system. And when we say perform well, it should be both in terms of cost as well as the processing time. So it should be able to reduce the cost and decrease the processing time basically. Okay, so both on the reduction front. Cool. So problem it is solving is priority propagation. How it is done? So how you are doing it is better priority propagation among the services. Now what you are doing it here is it's much similar to request tracing. If you see microservices, right? Uh, and let's say you want to trace a single request among the services, what you do? You add some kind of request ID. So similar thing you are doing here. As request is assigned a priority, okay, from the first front, from the edge. So a priority is defined there, and that same priority is propagated across the chain of callers. When I say chain of callers, it's the like bunch of microservices which are coming in between, which talks to each other to figure out a result of specific operation. Cool. So priority is propagated across the services. If not, let's say if the priority is not propagated, then Cinnamon middleware, it's basically a software which is embedded into the 𝐌𝐴RPC framework of Go. Okay, so which we again discussed in our previous video, but yeah, so it is a software system which is, there are multiple components in this software system. We will be discussing that, but yeah, it will figure out if there is a priority assigned or not. If there is no priority assigned, then it will set it to default one. One is basically, you can say, not very less priority and not a kind of mid. Okay. uh, cool. Now the priority is defined on based on two factors. First factor is tier level, another factor is cohort. Let's quickly try to understand what both these terms mean. So when I say tier level basically means that you have defined a severity of this priority. Okay, it is much similar to, again, you can take analogy of the tickets you get in the on-call cycles. Okay, so whatever tool you are using, there is generally a severity assigned to a ticket, like how quickly you should be able to resolve this ticket basically. Okay, uh, or the issue, whatever term you are using in your organization, you should be able to resolve that issue as per that priority. Okay, so it's, let's say, sev 0, sev 1, sev 2, similar on the similar concept. It is tier 0 to tier 5. Tier 0 is highest priority and tier 5 is lowest priority. So the priority should be defined accordingly. Cohort is basically, if you go by the general meaning of term cohort, it's a group. Okay, so what we are trying to achieve as part of cohort is that it should not happen when you are shedding the request always the same users are impacted. So we want to ensure by some mechanism that if like load is shedded continuously by our services, then the users should be changed, so that not same user is impacted again and again, and that experience is not, like what you say, hampered for the same customer again and again. Okay, so that's where cohort comes in picture. So it's a basic design algorithm works based on the hashing. So it figures out based on the timing, and then assigns a cohort from 0 to 127, which user belongs to, and at a particular time a certain set of users will be dropped from that cohort if the request has to be sedded, has to be dropped off. Cool. Now moving further, the architecture. How does our system work? How Cinnamon works? So your request comes in, your request comes in, and once the request has arrived, you have to figure out if the request has to shredded, dropped, or it has to be processed. Now, how can you do that? How will you be able to do that? How will you do that? So there are a couple of components, or you can say modules, which are part of this software, cinnamon software, cinnamon framework, whatever you want to say, cinnamon system. There are certain modules which works in a synchronous fashion, and it is kind of an orchestrator. Okay, you can say as an orchestration system, there are multiple steps which you have to go through, and you have to pass each and every step to see if it is finally reaches to the business logic or not. Okay, cool. So this is first one. The first component is, first module is ensure priority. So this basically checks if the priority is assigned to the request or not. If it's not assigned, as we mentioned earlier, a default is set. Cool. That's the part of easy operation. It basically checks the priorities, kind of a validation layer. Cool. Then comes in rejector. Rejector as in रिजेक्ट कर देता है सबको, सबको नहीं करता भाई, किसी किसी को रिजेक्ट करता है जो हमें एक्चुअली में शेड करनी है रिक्वेस्ट. So it basically checks if the request has to be rejected or accepted. Okay, and it works on the basis of PID controller. PID controller helps this rejector to figure out if this request has to be shedded or accepted. And again, as I mentioned earlier, we will be discussing PID controller, what is PID controller, in our next video. Uh, then let's say the request is not rejected. If it's rejected, then the rate limiting error is returned. Okay, if it's accepted, then this request is added to a priority queue. Priority queue basically means the request is added as per the priority which you receive in the request. So as per that priority, this request is added to the priority queue. Once this request is added to the priority queue, then comes in, you have to process this request, right? As soon as this request is present in our priority queue, you have to process it. So scheduler helps with that job. Scheduler, what scheduler is, what what scheduler do? Scheduler see how many requests has to be batched or processed in a parallel based on some number. Okay, and auto tuner component, which again is another component, other architecture or a module which we will be discussing in another video. But yeah, auto tuner helps it with what is the number of requests that has to be processed simultaneously, and this is decided as per the basis of what is the current load on the system, so that the response latencies are not compromised. Okay, the system, or like the latency to process a particular operation, is not that high. So if it's not that high, then more requests are processed. If it is high, then the batch size of the requests that are processed by that system are reduced. Timeout. If too many requests are queued, then it will time out with a rate limiting error. So let's say if a lot of requests are added to the queue and there is no time, like rejector past that request, that yeah, go ahead and process it, but later on you figure out that the queue is full and there are so many requests that are there in the queue, so it will time out with a rate limiting error based on a certain thresholds, the timeout which is figured out. PID controller. So as I mentioned earlier, right, PID controller works with the rejector and auto tuner works with the scheduler. So auto tuner helps in to figure out the limit, in flight limit basically. What is the limit that that is to be used to, like a limit to figure out what is the number of simultaneous or parallel request that has to be processed. And PID control is basically, it helps in minimize the number of queued requests somehow. How can you minimize the number of requests, and how will you minimize the number of requests? You have to ensure that the requests are processed as soon as possible. As they arrive, they should be processed. Now let's quickly talk about rejected and scheduler, and we will end this video. So rejector, what is the job of rejector? Rejector figures out if the request has to be accepted or rejected. How will it do it? How will the rejector do it? Figure out if endpoint is overloaded. Okay, if it's overloaded, then set a percentage of request based on a cohort. Cohort is one of the parameter which we are using in the defining priority of the request, and based on that cohort the requests are dropped. So let's say you figured out these are the tier 5 requests, and you can drop a 5% of users from this particular cohort. So that's how you are doing it. Now how will you figure out if an endpoint is overloaded? What you do, keep track of last time the request queue was empty. If not emptied in last 10 seconds, endpoint is identified as overloaded. This basically means that requests are taking more time to process it. Okay, if the requests are pending in the queue for longer time, the queue is not emptying out, that means the queue is being overloaded. Okay, that's the basic idea behind it. And if it's overloaded, then you monitor the inflow and outflow of request into the priority queue PID controller to determine ratio of the request to set. And in the next video you should be able to get clarity on how PID controller works, but it basically helps to minimize the number of requests. Now coming to scheduler. On the scheduler front, request is moved to priority queue on acceptance from the rejector. This we already we already discussed that once request is accepted, based on an in-flight limit, the requests are processed. So scheduler ensures certain number of requests are concurrently processed, called as in-flight limit, which is figured out with the help of auto tuner. In-flight limit is calculated by auto tuner based on Vegas TCP/IP control algorithm. If latency goes up, in short, if latency goes up, service is overloaded because requests are taking more time for processing, so you have to reduce this in-flight limit. If the latency is dropping, if the system is taking too less latency to process the request, so we can assume that our system is working great, and it is taking very less time to processing, so you can increase that limit, in-flight limit, to process more requests simultaneously. So this is all about Cinnamon, how it helps, how it is an improvement over QALM architecture, and how it helps Uber systems to work at scale, serving the customers in the scenarios of unexpected load experienced by the systems. So I hope this was helpful to get insights, and this will be helpful to design your systems in your organizations or whatever projects you are working on. We will meet again with another videos, and in this series we will be discussing PID controller and auto tuner. Till then, stay safe. Tata. Bye bye.